Hello friends and welcome to a lecture on operation research. Today we'll be looking into a transportation problem, but this transportation problem is unique in the sense that it has an unbalanced supply. I am Professor Arvind Prasad. We'll be using the Vogel's approximation method to solve it because this gives you the near optimal solution, and we'll look into it that it really gives, we'll find it out that it really gives the near optimal solution. So here we are, the problem is on your screen. We have plants A, B, C, D. That is, we have 4 plants. Their production capacities are given on the right. That is, in the rightmost column, you have the production capacities. Plant A has a production capacity of 50, plant B 70, plant C 30, and plant D 50. Well, the demand from the stores, that is stores number 1, 2, 3, and 4, is 25, 35, 105, and 20. Now, as you can see here, that the production capacity is more than that of the demand. Now, how do you optimize the allocations? And see to it that you allocate the units of the product produced in such a way that it meets the demand and the cost is minimum. Of course, you are going to have some excess units which you will have to adjust somewhere. Now, how do you adjust this? You adjust this by creating a dummy store. Now, your 5D is your dummy store. Now, this dummy store, the maximum demand is going to be 15. This is nothing but the difference of 200 and 185, which is nothing but the difference in the excess production minus the demand. Now, having done that, we'll use the Vogel's approximation method to solve this problem. So for this, we will have to calculate the cost penalties. So let's go ahead and do it. Now, what is penalty? Penalty is the difference between the least cost and the second highest cost in any row or column. Now, to explain this, let's take row number 1. The least cost, of course, is 0. The second highest cost is 2. So the difference between 2 and 0 is 2. Now 2 is the penalty for row A or row number 1. A similar reasoning goes for row number 2. So here it is 5 minus 0, that makes it 5. A similar reasoning, of course, goes for row number 3 too, where the difference is going to be 3 minus 0, that makes it 3. Now let's explain a column. Now in column number 1, which is store number 1, the least cost is 2 and the next highest is 4. So 4 minus 2 makes it 2. So the penalty here is 2. A similar reasoning goes with calculating the penalty 1, 1 and 2. Of course, the penalty of column 5D is 0. Now, how does the allocation proceed in Vogel's approximation method? The allocation is always done in the row or the column which has the highest penalty. Now, the highest penalty is in row B or row number 2. So we start with the allocation here. Now, coming to this row, the least cost here is 0. So we go ahead and allocate. Now, what is the maximum we can allocate here? The maximum we can allocate here is 15 because the demand in 5D is 15. So from plant number B, which has a capacity of 70, we allocate 15 to satisfy the demand of 5D. That's it. We are done. So the balance here is written, that is 55. And of course, here 5D is satisfied, so the balance is 0. Now remember one thing, in the future penalty calculations, column number 5D will not appear because now it has been satisfied. There we are. So under column D, now we put an X. Now we start calculating the penalty for 1, 2, 3 and 4. That is columns 1, 2, 3 and 4. And of course, the penalties are going to remain the same, 2, 1, 1, 2. Now coming to the penalties in rows. Now in row number 1, again it is 4 minus 2, that makes it 2. Now again here it is, see, remember here, now 0 doesn't come into picture because the column 5D has been removed. It's removed from our calculations now. Now, so here it's going to be 4 minus 2, that makes it 2. And the second calculation is now going to be 7 minus 5, that makes it 2. The third calculation, of course, here is now 9 minus 3, that makes it 6. And the fourth penalty calculation here is 4, that is 6 minus 4, that makes it, 4 minus 3, that makes it 1. Pardon me, slip of tongue. Now we know the highest penalty here is 6. So we again go ahead and allocate it in this row. Now we find the least cost in this row. The least cost here is 3. Okay, so we have to allocate here. Now the allocation, the maximum allocation that we can do for store number 2 is 35, but the maximum supply from plant number C is 30. So all of this 30 can now be supplied to store number 2 at the cost of 3. So we allocate it. Now, of course, all the allocation, all the production from plant number C has now been allocated, totally allocated. So this will again not come in our future penalty calculations like it was for 5D. So we go ahead with the further penalty calculations. Now, of course, the penalty calculations, you have to remember here, C is crossed out, even 5D is crossed out. So therefore, the penalty calculations here are again going to be 4 minus 2, that makes it 2. And then, of course, 5 and 7. So 7 minus 5, that makes it 2. And then 4 minus 3, that makes it 1. And I have crossed out 5D, of course. So now the penalty calculations, fresh penalty calculations here. Now remember one thing, we cannot take any value from plant number C. So the fresh calculations now are going to be again 4 minus 2, that makes it 2. Then of course 6 minus 4, that makes it 2 once again. And then this is followed by 7 minus 6. Okay, that makes it 1. And the last calculation that remains here is nothing but 5 minus 3, that makes it 2. Now we have come a tie in the penalties, where you have penalty 2 repeated 5 times. And then this is followed by penalty 1. Now the highest penalty, of course, here is 2, but which penalty to select? Now this is known as a penalty tie. Whenever you have a penalty tie of this kind, find that which penalty has the least cost. I'll explain this. Now for penalty number 2 in row number 1, the cost is 2. The least cost is 2. Now similarly for column number 1, penalty 2, the least cost is 2 once again. But if you go to row number 2, the least cost here is 5, which is higher than 2. And if we come to column number 2, the least cost here, of course, is 4, which is again higher than 2. So naturally, we have to select 2. Now the question comes whether I select the row or the column. Well, it actually, you have to, from the row, you have to allocate to the column. So it really doesn't matter. You have to, of course, here row is higher, so you have to select the row. So we select row number A, that is 1. Now the maximum capacity here is 50. And the maximum allocation that you can do in this column is 25. So we go ahead and allocate this off. So now remember one thing, in the future penalty calculations, column number 1, column number 5D, and row C, that is the third row, they will not appear in our penalty calculations. There we are. So slowly, as you can see, we have reduced our calculation effort now. Now, if you calculate the penalty for column number 2, this is going to be 2 because it's going to be 6 minus 4, that makes it 2. Now, in this case, it is going to be, that is column number 3, it is going to be 7 minus 6, which makes it 1. And in the case of column number 4, it is going to be nothing but 5 minus 3, that makes it 2. Now, coming to row number 1, we have not crossed it. Why? Because there is unmet units here. That is, some units have yet to be allocated to the stores. Therefore, we cannot cross it off. Similar reasoning goes for row number B2. So here again, when we have to calculate the penalty, we are going to now take the next highest, because now 2 has been crossed out. Cost 2 has been totally satisfied out. So the penalty calculation here is going to be 6 minus 4. That is again 2. Now here the penalty calculation is 7 minus 5, that is 2. And here in the row number D, the penalty calculation, of course, is going to be 3. And here we have 4. So 4 we cannot take because this is already satisfied. So we have 3 here. Then we have 6 here. So it's going to be 6 minus 3. That makes it 3. Now let's go ahead with the allocation. The highest penalty is in row number 4. So we have to allocate 50 now. Now this is to be allocated at the minimum cost, which is nothing but 3. But the maximum allocation to column number 4 can be 20. So we go ahead and allocate this. So the balance 30 is written here. And of course now column number 1, column number 4 and column number 5 will not appear in our penalty calculations. Similarly, row number 3, that is plant C, this will also not appear in our penalty calculations. So let's go ahead. So we have appropriately put a cross here because these columns do not appear in the penalty calculation here. Now the new penalty calculation, of course, is going to be 6 minus 4, that makes it 2. And then here it is going to be 7 minus 6, which makes it 1. And of course, the penalty calculations here are going to be 6 minus 4, that makes it 2. And now here the penalty calculation is going to be only between 7 and 8. So this is 8 minus 7, that makes it 1 here. And of course, only these two columns appear in the penalty calculation, that is column number 2 and column number 3. So the difference now here is going to be 8 minus 6, that's 2 once again. Well, the similar reasoning also applies for row number 1. Now, here we have the penalties as 2, 1, 2, 2, 1. Now, again, we have a penalty type. Now, in this penalty type, we have to look at the least cost. So, the least cost is going to be limited to 4, 6, 8, 7, 6, 8. And the least cost, of course, is 4. So, we have to allocate here. Now what we can do is here 25 is remaining and okay. So we had to allocate 5 here. That is because as you can see 5 was remaining here. 30 was already allocated to column number 2. Now 5 was remaining. So from that 25 we just allocate 5. Now the demand for store number 2 is completely satisfied. Now store number 1 demand, store number 2 demand, store number 4 demand and store number 5 demand are totally satisfied. Okay. Therefore, now what do we have? We are only remaining with the store number 3 demand. Okay. Now, of course, there is no leeway, that no need to do it, because now all the excess capacity that you have or excess production that you have, what is remaining or what is unallocated, that has to be, of course, allocated only to store number 3 and at the appropriate costs. So we go ahead and we do it. And there we have our answers. Okay. So if you go to see, this is our final allocation table. Now, the minimum number of allocations, that should be m plus n minus 1, that is 8, and the allocations that we have done is 8. So is this a feasible solution? The answer is yes. Now remember one thing, what did I tell you in the beginning? That Vogel's approximation method gives you the near optimal solution, not always the optimal solution. It might end up giving you the optimal solution. There are tests in optimality which you have to do, which you must be aware of. But it gives you a near optimal solution. Now the near optimal solution answer here is 965. Now I have used the computer to calculate the optimal solution. And you can see this is on your screen. Now, what has exactly happened here? The 30 that was allocated to store number 3 here now has been split up. It has been split up as 15 here. So this 15 has gone. This 30 has been shifted here as 15. And this 15 again, as you can see here, has been shifted up to column number 1. So column number 1 accordingly has been readjusted. The 30 that was additional here has been readjusted here and readjusted here. Because if you look at the structure here, the 30 here was at a cost 8. We could easily reallocate here to a lower cost, that is 4, and a lower cost here, which is cost 0, and readjust the other costs. There's a way of doing it. There's a looping method of doing it. But as we can see here, we are pretty close to our answers. Okay, so that was all about whenever you have excess supply and lower demand, how do you adjust it? And how do you allocate it so that you get the minimal costs for allocation using the Vogel's approximation method. That's the end of my lecture, friends. I hope you have enjoyed it and you have learned two things. What is Vogel's approximation method? And of course, when the supply is higher than the demand, how do you do an allocation? If you like this video, do send it over to your friends, like and subscribe, and do write comments on what exactly you want so that I can make more such interesting videos. Fine, guys, have a great day and have a great time.